Bucky wants to create a passcode for his cell phone consisting of 6 digits. He wants the passcode to start with 1, 3, 6, or 9. If repetitions are not allowed, how many ways can this be done? First thing we need to ask ourselves is, does the order matter here? We're talking about passcode, so order does matter, which means this is going to be a permutation. Okay, permutations will be blanks and then numbers in those blanks. So how many blanks do I need? He wants a passcode with 6 digits, so 6 blanks. So all of these are digits. And then there is a restriction. He wants the passcode to start with 1, 3, 6, or 9. So at the beginning, it's going to be 1, 3, 6, or 9. Okay, and now we go through and write down for each blank how many options we have. So starting with the blank that is most restrictive, which is the first one. So he wants only 1, 3, 6, or 9. So how many options do we have? 1, 2, 3, 4. And now for the other blanks. So the other blanks could be anything. Digits are 0 through 9. So normally that would be 10 options. But the question is, are we allowed to repeat things? So it says here that repetitions are not allowed. Okay, which means we do have to reduce. So normally 0 through 9, 10 options. But because we already used one digit already in the first blank, we have to reduce by 1 to 9. And then for the same reason, we have to reduce by 1 again to 8, 7, 6, 5. So final answer, 4 times 9 times 8 times 7 times 6 times 5. My closet has 34 shirts. How many ways can I choose 12 shirts to pack for my summer vacation? First question, does the order matter here? Does it matter what shirt I pick first, second, third, or 12th? It doesn't, right? So I'm picking the 12 shirts, putting it in the suitcase, so it doesn't matter which shirt I pick first, second, or 12th. So because the order does not matter, this is a combination. For combinations, the final answer is going to be something, choose something. First number is the total that I have to choose from. I have 34 shirts total, so 34. Second number, how many am I choosing? So I want to choose 12 shirts. So 34 choose 12. So for combination, we are going to go use our calculator and get a final answer. So on my calculator, you're going to click on FUNC. And then at the bottom, NCR. And then the way you enter it is 34, 12. And our final answer is 548,354. .040. So 548,354,040. Ken wants to make up a computer password containing 5 characters. He wants the characters to alternate letter, digit, letter, digit, letter, with repetitions allowed. How many different passwords can he make up? First question is, does the order matter? We're talking about passwords here, so the order does matter. So this is going to be a permutation. Permutations, we're going to use blanks and numbers. So how many blanks do I need? He wants a password containing 5 characters, so 5 blanks. And then he wants it to alternate letter, digit, letter, digit, letter. No other restrictions. Okay, so letters, that's A through Z. A through Z, how many options do we have? A through Z, it's 26. Digit, that's 0 through 9. How many options is that? So 0 through 9, 10 options. And then our second letter, and we have to ask ourselves, are we allowed to repeat? So for this one, repetitions are allowed. So if repetitions are allowed, we don't have to reduce. So letter A through Z, the full 26. Digit, once again, we are allowed to repeat. So we have the full 0 to 9, that's 10. And then letter again, the full 26. 26 times 10 times 26 times 10 times 26. So that's how you'll enter it on the assignment. Natasha wants to create a password by rearranging her student ID number that. How many different passwords can she create? We're talking about passwords here, so order does matter. So this is a permutation. And because we're rearranging a word that has repeated characters, this is a permutation with lookalikes. Okay, so how many blanks do I need? I need a blank for each character in this word. So that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, for the first blank, how many options do I have? I have 1, 2, 3, 4, 5, 6, 7, 8. 8 options for the first blank. And then because we're rearranging the word, we aren't going to repeat. So because I can't repeat, I have to reduce to 7, 6, 5, 4, 3, 2, 1. Now, because it's a permutation with lookalikes, I now have to divide by the characters that are repeated. So what's repeated? I have 3s that are repeated, and it's repeated 1, 2, 3 times. Okay, so I have to divide by 3 factorial. Okay, and that's 43 threes. Okay, so the factorial is how many times the character repeats. What else is repeated? I have a 9, so 1, 2, 3 9s. So that's another 3 factorial. And that's for the 3 9s. Okay, notice I didn't divide by 9 factorial, right? It's not the actual thing that repeats, it's how many times it repeats. And then I also have a 2 that is repeated twice. So that's a 2 factorial. And we're going to divide by 2 factorial. This is because of the 2 2s. And the way you enter this is as a fraction on top, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. On the bottom, 3 exclamation mark times 3 exclamation mark times 3 exclamation mark. So don't forget the multiplications in between. A team of 11 bowlers will be selected from a group consisting of 14 left-handed bowlers and 18 right-handed bowlers. How many ways can the 11 bowlers be chosen? Question, does it matter the order that we choose these bowlers? Does it matter who we chose first, second, third, 11th? We're just picking a team here, so just a group of 11 bowlers. So it doesn't matter who we pick first, second, third, or 11th. What matters is who we pick. So this is going to be a combination. So for combination, it's going to be something, choose something. We're choosing 11 bowlers. And then what's the total from which we are choosing? So we're choosing total of everybody is going to be the 14 left-handed bowlers and the 18 right-handed bowlers. So 14 plus 18. And 14 plus 18 is 32. 32 choose 11. So for combinations, we are going to go to a calculator and find a final answer. So we'll click on Func, F-U-N-C, at the bottom, click on NCR, and then the way you enter it is 32, 11. Okay, and our final answer is 129,024,480. 129,024,480. Okay, next part. How many ways can the 11 bowlers be chosen so that all 11 are right-handed? So if I want all 11 right-handed, instead of choosing from the entire 32, I'm just going to choose it from the right-handed bowlers. So how many right-handed bowlers are there total? There's 18. Okay, so if I want all right-handed bowlers, I'll just choose my 11 from the group of 18. Okay, 18 choose 11. On my calculator, NCR again, 18 comma 11. 31,824. Okay, last part. How many ways can the 11 bowlers be chosen so that exactly 3 are left-handed? Okay, so keyword here is exactly 3 left-handed. What does that mean? So if I want exactly 3 left-handed, what I mean is I want 3 left-handed and the rest I want to be right-handed. So exactly 3 left-handed means 3 left-handed and the rest right-handed. How many is the rest? I want 11 bowlers total, right? So I want 3 left-handed and then the rest right-handed. So if I want 11 total, the rest would mean 8, right? Because 8 plus 3 will give me my 11. So exactly 3 left-handed means 3 left-handed and 8 right-handed. Okay, so I want to choose 3 left-handed bowlers and then 8 right-handed bowlers. So this is a multi-choose because I'm choosing 3 left-handed and then 8 right-handed. Multi-choose. So we're going to have something choose something and then something choose something. For my left-handed, I'm going to choose 3 from the left-handed group. So how many left-handed do I have? 14. So 14 choose 3 will give me my left-handed bowlers. And then I want 8 from the right-handed group. So how many right-handed do I have? 18. So 14 choose 3 and then 18 choose 8. So on my calculator, I'm going to do each of these separately. Okay, NCR, 14 comma 3, that's 364. And then 18 choose 8. NCR again, 18 choose 8. 43,758. Okay, and the way you're going to enter this is 364 times 43,758. So don't forget the multiplication in the middle. License plates in a certain state follow the format 4 letters followed by 4 digits. In addition, the letters Q, I, O, D, S are not allowed. If repetitions are allowed, how many different license plates are possible? Okay, does the order matter? Yes, right? For license plates, the order of the letters and numbers does matter. So this will be a permutation. Okay, permutations are blanks and numbers. How many blanks do I need? 4 letters, 3 digits. So 1, 2, 3, 4. These are letters. And then 3 digits. Okay, go through and count how many options we have for each blank. Letter. So normally it will be A through Z, which is 26, but we cannot use Q, I, O, D, S. So 26 minus these 1, 2, 3, 4, 1, 2, 3, 4, 5. Minus these 5 letters, which would be 21 letters total, right? So A through Z, 26. If we subtract off these 5 letters, we have 21 letters total. So 21 options. Next letter, question is, are we allowed to repeat? Repetitions are allowed. So if repetitions are allowed, you don't have to reduce. So we have the full 21, 21, 21. Digit, that's 0 through 9. Normally that's 10. Next digit, because we are allowed to repeat, we don't have to reduce. So we have the full 10, the full 10. Next part, what if repetitions are not allowed? Okay, so same setup. 2, 3, 4, so 4 blanks for the letters, 3 for the digits. Same restrictions. So letter A through Z is 26, but we have to remove these 5 letters here. So we have 21 options. Now, because repetitions here are not allowed, we do have to reduce. So 21, but we have to reduce by 1 because we chose 1 letter already. So now we're down to 20, down to 19, down to 18. Digit 0 to 9, okay, that's 10 options. And then because we are not allowed to repeat, we do have to reduce. So for the next digit, because I chose 1 digit already for the first digit blank, I have to reduce by 1 to 9 and then to 8. So to enter these, it'll be 21 times 21 times 21 times 21 times 10 times 10 times 10. And then same thing for the second part. 12 friends, including Lucy and Ricky, need to arrange themselves in a line for a photo. Lucy and Ricky need to be in the middle in any order with 5 friends on either side. How many ways can they arrange themselves for the photo? Question is, does the order matter for this arranging people in a line for a photo? Yes, it does, right? So like Lucy on the left, Ricky on the right, it's going to be a different picture than Ricky on the left, Lucy on the right. So the order does matter. This is going to be a permutation. Okay, permutations, blanks and numbers. How many blanks do I need? I want Lucy, Ricky in the middle, and then 5 friends on either side. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now the middle needs to be Lucy or Ricky. So Lucy, Ricky. And the other one will be the other person, so it's either going to be Lucy or Ricky. Okay, starting with the most restrictive blank, which is the 2 in the middle. This one could be Lucy or Ricky, so 2 options. And anytime we're talking about people, we're not going to repeat, right? So for this next blank, Lucy or Ricky, keeping in mind that we already chose Lucy or Ricky for the first blank here. So we're down to 1. Okay, and now for the friends. This blank here, how many friends do we have? So there's 12, including Lucy and Ricky. So if we take out Lucy and Ricky, there's 10 people left. For the same reason, we're talking about people here, so we're not going to repeat. So I do have to reduce down to 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so final answer, 10 times 9 times 8 times 7 times 6 times 2 times 1 times 5 times 4 times 3 times 2 times 1. I have 23 old video games that I want to give away to my 3 cousins, Andrew, Annabelle, and Ashley. I want to give 4 games to Andrew, 7 to Annabelle, and 3 to Ashley. How many ways can I do this? Question, does the order matter? So when I give the 4 games to Andrew, does it matter what I pick first, second, third, or fourth? It doesn't, right? So I pick the 4 games, put it in the bag, and give it to Andrew. So it doesn't matter what I pick first, second, third, or fourth. Same thing with the 7 games to Annabelle and the 3 to Ashley. So each of these, picking 4, picking 7, picking 3, are going to be combinations because the order doesn't matter. And because I'm going to be choosing 4 for Andrew, 7 for Annabelle, and 3 for Ashley, this is going to be, we're choosing multiple times. This is a multi-choose. Okay, so for the ones for Andrew, I'm going to pick 4 for Andrew. And then the first number, how many total do I have to choose from? 23 games total. So 23, choose 4. For Andrew, and then for Annabelle, I'm choosing 7. How many total do I have to choose from? Now, it's not going to be 23, right? Because I already chose 4 to give to Andrew, so I don't have the full 23 anymore. So it's going to be 23 minus 4. So what's 23 minus the 4 that I gave to Andrew? 19. So I should have 19 left to choose from to give to Annabelle. And then finally, the 3 that I'm going to choose for Ashley. How many do I have left total to choose from? So there was 19. I gave 7 to Annabelle. So that's 19 minus 7, which is 12. So 12 total left. And then I choose 3 of them to give to Ashley. So now on my calculator, I'll do each of these combinations separately. Okay, FUNC, at the bottom NCR. The first one, 23 comma 4. That's 8,855. Okay, next, 19 choose 7, NCR again. 19 comma 7, 50,388. And then finally 12 choose 3, NCR again, 12 comma 3, 220. Okay, final answer will be 8,855 times 50,388 times 220. So don't forget the multiplication in between. The club consists of 28 members, including Teresa and Julie. The club needs to choose a president, vice president, secretary, treasurer, and a historian. How many ways can this be done so that either Teresa or Julie is secretary and the other is treasurer? Question, does the order matter? So here it does matter because the order that we pick them determines their job, right? The first person will be president, second will be vice president, secretary, and so on. So the order here does matter. This will be a permutation. How many blanks do I need? I need a blank for each job. So one for president, vice president, secretary, treasurer, historian. So the first blank will be president, vice president, secretary, treasurer, and historian. Now it does say that I want either Teresa or Julie, secretary, and the other treasurer. So treasurer will be either Teresa or Julie also. Okay, go through and count how many options we have for each blank, starting with the most restrictive, which will be these two, secretary and treasurer. So for secretary, we want to be either Teresa or Julie, so 2 options. And then we're talking about people here, so we cannot repeat, so I do have to reduce. For treasurer, Teresa and Julie, that's 2, but I did already choose Teresa or Julie already. So I'm down to 1 person. And now for the other blanks. So the other blank, let's see, how many people do we have to choose from? 28 members total, but remember, we already have Teresa and Julie for secretary, treasurer. So we have to subtract off 2, which means there's 26 people left. So 28 people total, but then I took away Teresa and Julie because they are already secretary, treasurer. Because we cannot repeat, reduce, 25, 24. 26 times 25 times 2 times 1 times 24. A pizza restaurant has the following options for toppings. We have some vegetables and some non-vegetables. How many different 6-topping pizzas can a customer order? So to order this 6-topping pizza, the customer would choose 6 toppings from the list of toppings. Question is, does the order matter when they choose these 6 toppings? Does it matter which topping you pick first, second, third, 6? Probably not, right? They're all going to go on top of the pizza. It doesn't matter the order that you picked the toppings. So this will be a combination. So combination is going to be something choose something. We're choosing 6 toppings from a total of how many toppings total? So all the toppings together, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 choose 6. So for combinations, we are going to go to the calculator. Click on FUNC at the bottom, NCR, and then 13,6. Okay, final answer, 1,716. Part B, how many 6-topping pizzas has only vegetable toppings? Okay, so if I want only vegetable toppings, I would choose 6. But instead of choosing 6 from all the toppings, I'll just choose 6 from the vegetables. So how many vegetables do we have? 1, 2, 3, 4, 5, 6, 7, 8. So 8 vegetable toppings, choose 6 of them, and that will give me my 6-topping pizza that is only vegetables. So once again, on the calculator, 8 choose 6. NCR, 8,6, 28. Last part. How many 6-topping pizzas have exactly 2 non-vegetable toppings? So keyword here is exactly 2 non-vegetable toppings. What does that mean? That means I want 2 non-vegetables, non-veg, and the rest to be vegetables. Okay? So that's what it means by exactly 2 non-vegetables. 2 non-vegetables, and then the rest non-vegetables. How many would be the rest? I still want a 6-topping pizza, right? So 2 non-vegetables. How many is the rest? So I want the total to be 6. So the rest would be 4. Exactly 2 non-vegetables means 2 non-vegetables, 4 vegetables. So this is going to be a multi-choose. Where I choose 2 from the non-vegetable list and then 4 from the vegetable list. So first, I'm going to choose 2 from the non-vegetables. So non-vegetables total is, here's non-vegetables, 1, 2, 3, 4, 5. So 5 choose 2. And then for the vegetables, I'm choosing 4 from the vegetable list. Vegetable list was 1, 2, 3, 4, 5, 6, 7, 8. So 5 choose 2, and then 8 choose 4. So do each of those separately on a calculator. NCR, 5 choose 2, that's 5 comma 2, that's 10. And then 8 choose 4, NCR again, 8 comma 4, 70. And then our final answer is going to be 10 times 70. So 10 times 70. Karen wants to create an identification code consisting of 4 letters followed by 3 digits. She wants the code to start with 0 and end with 1, 7, or 6. The letter part cannot have repetitions, but the digit part can have repetitions. How many different codes can she create? Question is, does the order matter? We're talking about codes here, so codes are kind of like passwords. Order does matter, which means this is a permutation. Permutations are going to be blanks and numbers. How many blanks do I need? 4 letters, 3 digits. So 4 blanks for the letters, and then 3 blanks for the digits. And in addition, I have some restrictions. She wants the code to start with C or O. First letter needs to be C or an O. And end with 1, 7, or 6. So the last digit has to be a 1, 7, or a 6. Okay, now we go through and count how many options we have for each blank. Starting with the ones that are most restricted, which are the first and last. The first letter needs to be C or O. So how many options do we have? That's 1, 2 options. The last digit needs to be a 1, 7, or 6. How many options are there? 1, 2, 3, so 3 options. And now for the other blanks. Letter, so letter will be A through Z. Normally that would be 26. Question is, do I have to reduce? So it says here that the letter part cannot have repetitions. So if you cannot have repetitions, you do have to reduce. So A through Z, normally that would be 26. But because I already chose one letter for the first blank already, I should be down by 1 to 25. And then again, I should be down again by 1 to 24, and then down again to 23. Okay, that's the letters. Digit, that's 0 through 9. Normally that would be 10. Question is, do I have to reduce? It says here the digit part can have repetitions. So if you can have repetitions, then you don't have to reduce, which means that I should have my full 0 to 9, which is 10. Okay, digit, once again, I should have the full 0 to 9, 10. So final answer is going to be 2 times 25 times 24 times 23 times 10 times 10 times 3.